All right, here we go, 17.4, 17.5, starting with addressing acid deposition on page 469. So first sticky note is talking about atmospheric deposition or depositing of things. So wet or dry deposition or depositing of pollutants on land. That's what atmospheric deposition is about. So the acid rain is the most well-known form of this atmospheric deposition. And it comes from burning fossil fuels, which we've talked about before. Now the sulfur dioxide and the nitrous oxide from like factories and from cars, they turn the water acidic. So this picture on the bottom here, 1728, I like this picture a lot because it talks about the primary and secondary pollutants, which we've discussed, and it shows how the pollution from a city can hurt the rural areas far away. So you can see sulfur dioxide, nitrous oxide, factories and cars are pushing this whole stuff out. Then water, oxygen, and oxidants in the atmosphere, combined with sunlight, that's the energy that makes this whole thing happen, creates sulfuric oxide. You can see H2SO4. It started as SO2. And it also creates nitric acid, HNO3, which started as NO. So this is the primary and secondary pollutants. It starts off as this, goes through transformation, becomes a secondary pollutant as that. So I like that image a lot to kind of really give a visualization of what's actually occurring. All right, so now 470. So the pH is determined by the number of H plus ions. And I'm hoping that you learned that in biology or in chemistry as well. So the higher amounts of those H plus ions, the lower the pH or the more acidic the solution is. Now acid rain mobilizes or basically makes it so these toxic metals can start to move around or basically become soluble or change form into something else. Now that's obviously bad because the runoff from the land with those toxic metals can absolutely decimate the rivers and the lakes too. So if a whole bunch of aluminum is getting into a lake, it's going to kill a whole bunch of things off. This picture here, you can see just the damage of acid rain. You can see before and after. Look at the detail of that versus afterwards. Really, really big change. And then the table, you can see table 17.1, walks through a little bit more of those as well. All right, moving to 471. It's talking about a thing called the acid rain program. Zoom in a little bit on that so you can see it better. So it's created under the Clean Air Act. It was made in 1990. It created what's called an emissions trading system for sulfur dioxide. And on page 179, and even says in the text up there, page 179 has more information about it. And honestly, it's a really interesting read, and honestly, one thing you guys should be familiar with. You can say emission trading can produce cost-effective results. You should read, honestly, that page because it's a really good understanding of how this whole system works and how it can incentivize companies to clean up their pollution. And like we've talked about before, if you can incentivize the private sector to do stuff, things will happen. And so far, there have been very, very, very positive results. So this picture over here, again, like we've talked about, like basically our air quality has gone up over time. Look at this, from 1990 to 2014, so basically 24 years. Look at the pH difference in precipitation. Look how acidic it was, basically almost the entire eastern half of the United States. Look how much that's been cleaned up. Again, incentivize the companies and big change will happen. All right, so now moving on to 472. Oh, wrong direction. All right, we're talking about ecosystem rebuilding. Uses calcium influx. Now, indoor air quality can have high concentrations of pollutants, which you guys are experiencing right now. You know, you're looking at like inside versus outside, you know, a bedroom versus a kitchen and whatnot. You're seeing just the number of particulates that are in the air. Now, air can be trapped inside with particulates from cleaners to coal burning to animal dung. So basically, a whole bunch of things can be stuck in the air in your house. So you can see here, figure 1732, the caption, in the developing world, many people build fires indoors for cooking and heating. But think about that. If you got an open fire inside, a whole bunch of particulates are getting into the air. And that's becoming a really, really, really big problem. So in 473, it talked about this. So tobacco smoke and radon are the worst in developed nations. Now, I'm not sure if you guys had like grandparents who smoked or something like that. One of my grandfathers smoked, and I remember walking into his house, and it just smells like it. So that means there's a whole bunch of those particulates in the air. So the radon, you can see here in the United States, luckily you can see here in Washington, we're pretty low because it's based on the geology. So like think of like Yellowstone National Park going on around there. That's one of the big reasons radon's a big deal. So you can see what radon is. It's a radioactive gas from decaying uranium in the soil. So lots of good smells are also bad for you. So think of, like, oh, the candle, I should light some candles in my room. I should light some candles here and candles there because, oh, it smells good, it smells good, it smells good. There's a lot of particulates in good smelling things. So pollutants can come from you and your pets and other living things. You got dust mites, you got pet dander. All of those things, it just like leads to like the natural odor, and that's not necessarily a good or a bad term. Just simply the odor of your house is based on, the air cleaners you guys are using, the Febreze, the candles, the everything that makes your house what your house is. All right, big diagram here. Got a lot going on. And like I said there, know this diagram. There's a lot of things happening here. So basically know this because you can use these as examples for stuff. You talked about tobacco smoke. Talk about computer and office equipment, the rocks and soil beneath the house. You got pets, you got fireplace wood stoves, you got heating and cooling ducts, you got furniture, you got all the different things can affect the quality of air in your home. Basically think of any of it. All of it can affect it. One of the things that's interesting, and I wanted to point out, it's actually underneath my little sticky note here, is, there we go. Progress is being made worldwide in alleviating the health toll of indoor air pollution. Researchers calculate the rates of premature death from indoor air pollution dropped nearly 40% in 20 years. So that's really good. So we want to talk about optimism in environmental science. In 20 years, look how much we've done. So focus on that kind of optimism, that if we put our minds to it, we can really make some positive change in a short amount of time. All right, leave some questions so we got stuff to talk about.